Today we are discussing that what is homo and what is link, because yesterday we are discussing Diels-Alder reaction. Today we are going to discuss Diels-Alder reaction. In Diels-Alder reaction, the diene and dienophile is there. Diene, we yesterday saw that there is FMO approach, frontier molecular approach. We see that there is only two things, homo-LUMO. What is homo and what is LUMO? Homo is highest molecular orbital, and LUMO is lowest unoccupied molecular orbital. Good morning, Anshika. Good morning. A very good morning to you, all of you. So today we are going to discuss what is supraspatial, what is intraspatial. So many people or so many students, they don't know about what is intraspatial, what is supraspatial, how we are correlate with them, and how they are allowed and how they are not allowed or forbidden. So today we are going to discuss supraspatial and intraspatial, and now we see after that we see that which is thermally allowed condition and which reaction is photochemically allowed condition. Okay, good morning Sheetal, a very good morning to you. So today we are going to discuss suprafacial and intrafacial, because so many students don't know how to approach or how to think suprafacial and intraspatial, that topic and concept. Okay, so supraspatial and intraspatial, what does it mean and which condition they are allowed or not. So today we are going to discuss chemistry study point. गुड मॉर्निंग चल रहा है अभी. ऋतुराज भोसले, a very good morning to all of you. Which those who are watching or the language, no, this is actually English medium, that's why I'm going to take it in English language. No problem. If you have any doubt after the lecture, you can call me, message me. If you have any doubt, you can ask me. There is no any other option. Okay. Whether I am explaining in Hindi also, that's not a big issue. But we are suggested that please take it in English. Okay. So Diels-Alder reaction. We know in Diels-Alder reaction, yesterday we saw that diene plus dienophile. This dienophile will react here, this pi bond shift here, and this pi bond will attack. In heating condition, it will become how many member ring? 1, 2, 3, 4, 5, and 6. How many member ring is formed in product? 6 member ring is formed. Okay, my voice is clear or not? Please tell me. Voice is clear or not? Sir, voice is not clear. Voice is not clear. Wait. Now clear or not? Tell me, just tell me. Now clear. Wait 5 minutes. Now clear or not? Just tell me. Now clear, Anshika? Not now? Not clear? Am I audible or not? Just tell me. Anshika, am I audible or not? Hello? Am I audible right now? Am I audible or not? Yes? Clear? Yes, clear. Okay. So today we are going to discuss homo-LUMO approach of that. We saw that in heating condition, diene homo in thermal condition what we get? Psi 1, psi 2 or psi 3? Please tell me. Psi 1, psi 2, psi 3, which we get in diene HOMO in heat thermal condition, which we get? Psi 1, psi 2 or psi 3? Please tell me. Psi 1 or psi 2? Psi 2 we get, and psi 2 is n terminal orbitals are plus or minus? They are plus or minus terminal. Yes, very good. Yes. So in uh, diene, HOMO is thermal condition psi 2. For the reaction, we take HOMO in the thermal condition psi 2 is plus and minus. And what is LUMO? LUMO, heating condition. Actually, we want only HOMO for the reaction of heating thermal condition and photochemical condition. So today we are going to take that HOMO in HNU condition. HNU condition, what we get, and which is the HOMO? Psi 1, psi 2 or psi 3? After next orbital is psi 3, because one electron is excited in photochemical condition. One electron is excited in photochemical condition, then that we know that in thermal condition we got psi 2, and one electron is excited to the next orbital, that is mean psi 2, after that psi 3, and psi 3 is n terminal is plus plus. Okay, so for the reaction with the dienophile, we want heating condition that HOMO is psi 2, and in photochemical condition we got HOMO is psi 3. We will chemical condition. Photochemical, or in the presence of light. Okay, in the presence of light we got HOMO, and we got HOMO for thermal condition, that psi 2 plus n terminal is plus. There is what is HOMO of this? Now clear voice? It's clear or not? Who told me? Clear? Voice is clear or not? Just tell me. Clear? Okay? Fine? Fine? Okay, sir, fine. Ashwini, now voice is clear or not? Srishti? हाँ, अभी आ रहा है? Okay? Fine? No? Not now? Clear or not? Clear? What happened? Clear? Clear or not? Clear. Okay, chalo. Then what we see? Homo and for dino homo. How we take silence? Clear? What? Clear? अभी आ रही है? अभी ठीक है या नहीं है? बताइए, आ रही है या नहीं ठीक से? आवाज माइक से नहीं ठीक है ठीक है ठीक है। अभी ओके? मधुकर, अंशिका, now voice is clear or not? No voice? Yes? Tell me, am I audible or not? Yes, now clear? Srishti, Madhukar, Anshika, Ashwini, now okay? Okay? Fine? So you, now you are clear. So we are that reaction take that diene and dinophile. So dinophile, we want LUMO. We want LUMO. LUMO, how I take in the thermal condition, LUMO is Psi2 and negative or positive sign. N terminal is negative and positive terminal in dinophile. In diene, the N terminal is HOMO. We take HOMO is Psi2 and N terminal is positive and negative. Okay, then we see that there is a bonding. Negative is there is showing bonding approach, bonding molecular approach. What we see, there is bonding. Okay, what we see, there is bonding. Okay, bonding. Here also we see that positive approach, positive approach. Here we see that this also show bonding. If they are showing bonding, it's mean formation of sigma bond or orbital interaction is, what is interaction? Positive positive interaction is like in pericyclic bonding. It's mean here positive or positive signs become one sigma bond, and this negative become one sigma bond. It's mean they are showing, they create or they making sigma star orbital, or we call a sigma bond they are forming. Okay, good morning Monica, a very good morning to you. So here, how many pi electrons are included in dyne? Tell me, how many pi electrons are included in dyne? Dyne, how many electrons are there? There are how many pi electron? Pi electron, how much electrons are there in pi bond? There are two electrons. Okay, so this is one pi bond containing how many electrons? Two electrons. And this pi bond also how many electrons? Two electrons. So total pi electrons how much? Total pi electrons how much? Good morning Rani, good morning, a very good morning Rani. So there are four electrons. Okay, so 4 pi 4 pi electrons. So we are showing like that pi 4, that is this positive and positive approach, showing that they are supraspatial. What does it mean? They are showing bonding from this side and this side also, so it is called as supraspatial. So this is supra, and here this is for dyne and this is for dienophile. How many electrons in dienophile? How many electrons are in dienophile? So in dienophile, sir, there are only 2 pi electrons, because they are reaction doing. How many pi electrons are there? 2 pi electrons are there, sir. Okay, so what happened? 2 pi electrons are there, so we are showing pi 2 supraspatial. Why we are showing supraspatial? And why we are showing supraspatial? Because they are happening bonding between the negative and negative orbital of dyne and dienophile. Why we are showing supraspatial? Tell me, what is the reason? Supraspatial. Supraspatial, why we showing? In with the reaction of dyne and dienophile, what happened? Dyne have that end orbital have negative and positive sign, and dienophile containing negative and positive sign. If negative and negative sign showing bonding between the orbital, so what happened? They are showing like supraspatial in between the dyne and dienophile. So this is called as supraspatial. What is called as? What does it call? Supraspatial. Supraspatial. You now you understand what is supraspatial, and this is LUMO of dienophile. So highlighted it properly. And heating condition, here we see that in heating conditions, sir, we take homo of dyne. Okay, homo of dyne. And what is homo of dyne? Side 2, sir. In side 2, n terminal is positive and negative. Positive and negative, we take it. There we see that in the between the negative and negative orbital, formation of sigma bond, it's called as bonding. And there is only other one is also positive sign containing next orbital, end orbital is forming bonding. So sir, they are also showing bonding, and they are only including how many electrons? Pi electrons? Only 2 pi electrons, sir. But in the dienophile, dyne, how many electrons are there? 4 pi electrons, sir. Got it? How many electrons? 4 pi electrons, we got it. How many electrons are there? 4 pi electrons. 4 pi electrons we get, and we saw that here is supraspecial and here is supraspecial. Now it's become totally supraspecially allowed. So we are called as supraspecially allowed transition. So they are allowed or not allowed? They are allowed or not allowed? They are allowed. And how we decide they are all not allowed or not? We are discussing or see that this is terminal is negative terminal, and negative terminal showing bonding molecular orbital. This positive terminal showing bonding molecular orbital. Symmetrical approach or symmetrical attraction. So symmetrical approach we call as also symmetrical approach, and symmetrical bonding orbital in between. Same approach means symmetrical approach. Okay, unsymmetrical and symmetrical. This is symmetrical approach. What we call as symmetrical approach. Very good, very nice, Monica. This is symmetrical approach. Here also symmetrical approach, and here also symmetrical approach. Okay, symmetrical approach. Okay, so symmetrical approach. Here how we see symmetrical approach? Positive and positive sign. Symmetrical approach means negative sign. So this is supraspecial and this is allowed condition. What we call as allowed condition. So this is allowed in heating condition. They are allowed. In heating condition, they are allowed or forbidden? They are allowed in condition in heating, or thermally condition they are allowed. Thermal condition they are allowed. Okay, symmetrical approach, symmetrical bonding. Good, very good, Monica. Very good. History, very good. Very nice. So after that, what happened? After that, what happened? This is dine and dienophile. Okay, this is dine, and we take so many students, they don't know which dine for the reaction we take homo or lumo we take. So many students, they don't know which dienophile we take homo or lumo, because we want to know we take dienophile of lumo, we don't take homo. Remember that it is a very important point for you guys, because basics is very important in CSIR, NET, GATE, SET or any government exams. They are asking which is you take in dienophile, you take homo or lumo. We take homo or lumo. In dienophile we take only lumo. So highlighted it or got it that point. We take only homo, lumo of dienophile. We don't take homo of dienophile. We only take lumo. Okay, got it? Any problem, any issue? Now voice is clear or not? Please tell me. Now you understand the heating condition. Now we are seeing that. So we are see that further. This is heating condition. We are see after new condition in photochemical condition. So we are going to discuss now. So today now we are going to discuss that photochemical condition in the presence of light. The presence of light. So now we are discussing in the presence of light. Sir, What is the HOMO of dienophile in diene? Diene we take HOMO in which condition? H nu condition. In H nu condition, what we get? Psi3 or Psi2? Psi3, and Psi3 is positive terminal or negative terminal. N terminal is positive and positive terminal, sir. Okay. So positive terminal, we want only HOMO of diene. And okay, so we take HOMO of diene. Now we are drawing that this is diene. Okay, and orbital is important. N terminal orbital is important. Okay, so N terminal point is important. What happened after that? There are which terminal sign? Positive, and here there are negative terminal. Okay, after we saw that there is only two orbital, so this is what? So dienophile we have what we want in free condition we don't get dienophile, but before the excitation we got LUMO of LUMO of dienophile. And what is the dienophile? Before the excitation, plus or minus, this is plus or minus psi1 we take, and it is plus or minus terminal, and terminal is plus and minus. Okay, so what happened? There are bonding molecular orbital, and here we see they are bonding molecular orbital. Okay, it is bonding molecular orbital. Okay, this is bonding molecular orbital, but here we see that what we see here, you see that this is positive or negative side. This is positive and negative sign, so I am going to take it is positive and negative. So what happens, sir? So we take positive terminal and negative terminal. What happened? But there is something different. How we see that there is difference or not? But there is difference, minus sign, but there is plus minus sign. Okay, so what happens? You see that there is only plus. Symmetrical approach is by the plus sign. So here is plus. They are not in form of bonding. They are like anti-bonding. It's like anti-bonding. So here not a bonding formation. They are not a symmetrical approach. They are anti-symmetrical approach, and they are showing anti-symmetrical approach. What does it mean? They are showing anti-bonding molecular approach. They are showing anti-bonding molecular approach. Okay, and here positive terminal, they are showing bonding molecular orbital approach. They are showing bonding molecular orbital approach, and these are anti-symmetrical and these are symmetrical. These are symmetrical bonding, and they are anti-symmetrical bonding. Anti-symmetrical. Anti-symmetrical we call as anti-bonding. We call as anti-bonding molecular orbital, or anti-symmetrical we call as. Okay, so there is not a formation of that not a formation of bonding. So you see that this plus sign and this plus sign is different flow, not in the same side or in the downside direction, but here you see that there is negative approach is same side or symmetrical. This is supra or intra, or here we take that this dinophile we take. So now we are going to discuss that this is how many pi electrons? 4 pi electrons, sir. Pi electrons, how much? 4, and it is supraspatial, so it is S. S means supraspatial. If they are showing supraspatial and there is dinophile, and dinophile showing they are pi to intraspatial. Why we called as intraspatial? Because before the positive and negative terminal, N terminal is positive and negative terminal, and they are showing one antibonding molecular approach and one bonding molecular approach. That's the before the excitation of one electron, they are taking that psi 1. That's why we are showing intraspatial. Supra and intraspatial. What does it mean? This is homo, and this is lila. Okay, this is lila. Okay, so what happened? This is intraspatial. Okay, so if they are supraspatial and intraspatial, that is not allowed in nature. Okay, that is supraspatial and intraspatial. Pi 4 is supraspatial and intraspatial. If molecule containing dine or dinophile containing supraspatial and intraspatial, the molecule is not allowed. The molecule is not allowed. So molecule is not allowed. So what happened? Intraspatial interaction. Yes, Monica, very good. This is intraspatial interaction, and there is suprafacial interaction. Okay, so this is, you need to remember that there is not allowed. This is not allowed. One formula is derived from that. I will tell you which reaction is goes, or which is allowed or which is not, in which condition, in thermal condition, which is allowed reaction and which is photochemically not allowed. One formula is there. I will tell you how to take that formula or trick for you to which is allowed and which is not allowed. Okay, so I will tell you which is allowed or not allowed. So next, CSIR net exclusive live batch, life science origin batch, chemical science alpha batch, physical science gravity batch, mathematical लक्ष्य batch. ओके, स्टार्टिंग फॉर्म 8 जैन से स्टार्ट हो गई है, तो आप जल्दी से जल्दी एनरोल कर लीजिए. ओके, टू CSIR नेट फॉर सक्सेस. और आपको ये साइट दिख रही होगी IFAS.online.com, और ये नंबर भी है यहाँ पे. आपको जल्दी से जल्दी आप ज्वाइन कर लीजिए और एनरोल कर लीजिए और अपनी सक्सेस को दुगना कर दीजिए. ओके, सो you are going to take that, or if you have any query related to admission or course or any other study material, you can call on that number. Okay, 917-226-66888. Okay, so now in the below section you are saying that IFAS 70% giving 70% discount on all courses, live batches courses or recorded courses. Okay, so you want to take that coupon code IFAS 70. After that 70% applying that coupon code, you got 70% discount on every batch. Sir, there is also one announcement, exclusive English recorded course also there. CSIR NET June 2024 aspirants, for those who are preparing for June CSIR NET. So they will also take that, like all subjects are there. They for life science, chemical science, physical science and mathematical science, they are giving you, IFAS are giving you flat 70% off. So take this advantage and put their promo code IFAS 70 to avail this offer. So you can go on that website and you can call 917226688 number, and if you have an inquiry you can ask him. Sir, you know, or ma'am, you know there is a BARC exam. So if you are preparing for BARC exam, you can go and take that recorded course is there, and they are giving you flat 50% off. They are giving flat 50% off. So 50% off, you can apply coupon code IFAS 50. Okay, so you can enroll now and go for a success of BARC exam. So you can join it fast or enroll now in IFAS. Okay, so now we are seeing that how we derive that formula, because this is so very important for you guys, because we don't know which is allowed in thermal condition, which is chemical condition. This formula is very important for you guys in for CSIR NET exam, for GATE exam, for IIT JAM, for SET exam, for GATE exam, all exams. It is very important for you guys. So you are very focused on that formula. So what is the formula, sir? Here they are dinophile and dine. So here they are giving heating condition. How we decide that this reaction goes in the heating condition, this is allowed or not allowed? How we take or how we decide this is allowed or not allowed? How many electrons are there? How many pi electrons are there? 4 pi electrons is there. And how many pi electrons in dinophile? 2 pi electrons in dinophile. So what does it mean? Total pi electrons is 6. Total pi electrons is 6 pi electrons. Total pi electron is 6 pi electron system. How many system 6 pi electron system. How many electrons are including here? 4 electrons from dine and 2 electrons from dinophile. So total how much electrons are? 6 pi electron. So 6 pi electron divided by 2. 6 pi electron divided by 2, you got a 3, and this 3 is electron pair. Electron pair. And this electron pair, how much pair in the molecule, in the starting material? How much electron pair in the starting material? 1 pair containing 1 pi bond. And how much pair is there? How much pi bond are there? 1 pi bond, 2 pi bond and 3 pi bond. We get 3 pi electrons. This pi electron pair, not electrons, they are electron pair. Pair is different and electron is different. Total electron, how much in there? How much is total electron? There are 6 electron in that dine and dinophile, containing total 6 electron. But how much pair is there? Pi electron pair, there are only pi electron are there. Daneshwari Shahu, a very good morning to you and welcome you, a warm welcome to you, and see how we are deciding that which is suprafacial and which is intrafacial. After that, we are describe one formula which is heating condition is allowed and H nu condition is not allowed. We are deciding or we are creating one new formula for you guys. Now after that formula you can easily showing or easily decide that which is allowed condition and which is not allowed condition. Okay, this is 3 electron pair, sir. Pair is different and electron, pi electron is different. So you need to remember that this is 6 pi electron system. How much? 6 pi electron, and this is 3 electron pair, sir. That both are different. Pair is different and 6 electron pi electron is different. How? 6 pi electron is how much? There are 1 electron, 2 electron, 3 electron, 4 electron, 5 electron and 6 electron. This is 6 electron containing system. Okay, this is 6 electron containing system. And how much pair are there? Pi electron pair. How much pi electron pair is there? How much? One pair. This is 2 pair and this is 3 pairs, sir. Because how we got 3 pairs? We get like that here 3 pairs in the starting material. Okay, you got it. This is 3 pair. And how we get 3 pair? There only 1, 2 and 3 pair. So 3 electron pair we got, and 3 electron pair. How much total electron? Electron pair. Electron pair. You write here electron pair, not electron, not pi electron. You need to remember that. We see that electron pair on pi. So voice is not properly audible or not? Voice नहीं आ रही है. आ रही है ना? Sorry, audible is not audible. Anshika, voice is audible or not? Please tell me. Voice is audible or not? Please tell me. Is there any problem to related to voice? Voice is audible or not? Hello, please tell me. Voice is there or not? Please tell me. Audible? Not? No? Please tell me. Clear or not? No? Not clear? 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 Tell me. We are pair. We need to see that this is electron pair. We don't want to see. So many students is very confusing. They are taking 6 pi electron and they are seeing 6 pi electron. It's come A1 number. So they are confusing. Okay. So there is E1 electron one electron pair. This is now we are taking that or saying that in heating condition, what happens? In heating condition, what happen in heating condition? What happen in heating condition? So today now in heating condition, odd electron pair is allowed condition, but in HNU or photochemical condition, odd electron pair is not allowed, sir. After that, in even electron pair, heating condition is not allowed. But if you got total electron pair in HNU condition is allowed, sir. So this is one box you can it's remember it by. So here you got it that this is if you got odd electron pair. How much electron pair is there? 3 electron pair. 3 is odd or even? 3 is odd or even? Tell me. 3 is odd or even? This is 3 is odd. If they are odd, that means heating condition or thermal condition, this reaction is allowed. But in the photochemical condition, this reaction is not allowed. You got it? You got that formula? You got that formula or not? Please tell me. You got the formula? Clear? Concept is clear or not? You don't see 6 pi electron. If you are saying 6 pi electron, 6 is even number and even number thermally not allowed, then you are blunder here, because 3 is, sir, odd. And if you want to see that electron pair, what you see electron pair, not electrons in pi bonds. You need to see that total electron pair. So how you get total electron pair? You total the electrons in pi electrons, 1 2 3 4 5 6. So divided by 2, you got total pi electron pair. So after total electron divided by 2 and divided by 2, you got 3 electron pair, and 3 is odd. If the 3 is odd, if 3 is odd, you see that table in heating condition, thermal condition is allowed, but in photochemical condition not allowed. If you got next, if you are saying that, so you give me answer that allowed or not allowed. So if we take one question for you, this is 4 plus 2, this is dine and this is dinophile. It's which condition is allowed or not? Just tell me, 4 plus 2, which condition is allowed? Heating condition or HNU condition is allowed? Please tell me. Tell me in the comment box which is the allowed condition, thermal condition or photochemical condition is allowed. Please tell me the answer of this. Heating, Monica, very good. Please tell me. Daneshwari, Anshika, Ashwini. Clear? Concept clear? Now you are clear. This is very important formula for you guys. Please remember, there is electron pair, not electrons. Okay, this is electron pair. And if you want electron pair, divided by 2. Total electron divided by 2, you got 3 electron pair. If you got electron pair, now then see 3 is odd. If you got any even number is thermally not allowed but photochemically allowed. Okay, heating, got it? Clear? Concept is clear or not? Please say something. You got it something? Yes, Anshika, very good. So this is total. How much electrons are there? 4 plus 2. 4 plus 2, there is heatingly allowed condition. 4 plus 2 means 6 pi electron, and 6 pi electron divided by 2, you got 3 electron pair, and 3 electron pair is 3 is odd, sir, and 3 is odd. If we see odd number is here, and odd is put heating condition allowed. So here we put heating condition and it is allowed. Okay, after that we see that if I will give that, so next of there is heating condition H nu, odd electron pair allowed, not allowed. Okay, allowed, and even electron pair not allowed and allowed. Okay, this is the main box for you, and you draw here Gogi. Okay, you need to remember that Gogi. Okay, so Gogi is there, and Gogi will remember you that this formula. Okay, so if I will give you 2 plus 2, it is allowed or not? In which condition they are allowed? Please tell me. One question. Second question, please tell me. It is tell me. Tell me that this is 2 plus 2 is allowed or not? 4 plus 2, how much electron, and which is the allowed condition? Please tell me which is the condition allowed. Third question is which is allowed, photochemically or thermally allowed? Please tell me the answer of this. Sir, 4n plus 2 के टर्म में बताइए ना. हाँ, नैनेश्वरी, दैट 4n plus 2 ये कौन सा फॉर्मूला है सर? वो हीटिंग और एच न्यू का फॉर्मूला है. कौन सा? देयर इज वन फॉर्मूला रिलेटेड टू 4n and 4n plus 2. Okay, this 4n plus 2 and 4n electron, it's gone, and this, and this is this, and this is gone. Okay, so this one formula also there, so you need to remember that two formulas. Oh, okay, and I will tell you that 4n and 4n plus 2, so 4n plus 2 or 4n, but here only odd electron are come na, electron pairs. Here only odd electrons pair, and here only even. So even, you know, 0, 2, 4, 6, even electron pair if you got, then you decide that heating condition is allowed or not. And if you got odd means 1, 3, 5, 7, 9. Okay, odd number, if you got odd number, that is allowed or not, you want to see. Okay, so light condition allowed, both Anshika in light condition is allowed. Okay, Monica photochemical condition में allowed. Okay, no problem, good. 6 plus 4 is allowed in heating or condition, photochemical condition, which is allowed or not? Please tell me. Very nice, very nice, very good, very good. Naneshwari Shau, photo, heat, photo. Okay, very good answer. You are giving a very good answer, and you are very punctual and very focused. And in the exam, you need to remember the presence of mind is very important in the exam. So presence of mind is very important in the exam. So 2 plus 2. Okay, 2 plus 2, how much electrons are there? Total Total pi electrons 4. 4 pi electrons divided by 2. How much you got? 2. And 2 is even or odd? It is even, sir. Now Naneshwari, you understand or not? This is 2 and 2. How much? 4. 2 plus 2, how much? 4. 4 pi electron, and 4 divided by 2, you got 2. And 2, you need to see 2 is even or odd? Even, sir. If they are even, you need to see even. And in even, this which is allowed or not allowed? It's go in the H nu condition only, sir. If they are even, they are allowed in H nu or photochemical condition only. They are not allowed in heating condition. Okay. So you are listening or not? Okay, fine. Anshika, very nice, very good. So we are see that if they are giving you 6 pi electron and 4 electrons, now you are see that 6 electron plus 4 electrons means 10 electrons are there. If 10 electron is divided by 2, you got 5 electron pair, and 5 electron pair. And what is it? 5? 5 is even or odd? It's even or odd? 5 is odd, sir. If you got odd number, then you see in that table odd number you got, which is allowed, thermally allowed or photochemically allowed. Which if you got odd number, you need to see in the table box there is heating condition or thermal condition which is allowed in odd. If you got odd electron, which is allowed is thermal condition or heating condition. Okay, you got it? You see that yellow color is visible or not? Just tell me. Yellow color is visible or not? Tell me. Visible or not? Yellow color? Good. So here we got that odd electron pair and heating condition is allowed. Okay. So after that 6 pi electrons, 6 pi electrons. So they are giving 6 plus 6. How many total pi electrons? Total pi electrons is, sir, 12. Total pi electrons is 12, but divided by 2. If you are divided by 2, you got, hello, not visible. Okay, fine. I take blacks. Okay, so 12 divided by 2, you got how much? 6. 6 is electron pair, not electrons. You got 6 electron pair. If you get 6 electron pair, 6 is what? 6, what is 6? Even or odd? 6 is even. If you get even number, so you need to see in the table box. If you get 6 number, then 6 number is even or odd? Even, sir. If you got even electron pair, this is allowed in which condition? Only H nu condition is allowed in 6 plus 6 addition. Only H nu condition is allowed in 6 plus 6 Diels-Alder reaction. Okay, so today for 2 days it's you got that formula. You got that formula clearly. Concept is clear. Now you clear how to take which is allowed reaction and which is not allowed reaction. Now you are clearing. Anshika, Daneshwari, Monika ji, Anshika ji, Daneshwari ji. Now you are clearing, not clear or not? Please tell me. Vike Thuzo, you are from Nagaland or anywhere? Ashwini, you got it? Tell me, you got it or not? Clear? Concept clear or not? Please tell me. So for today's lecture only we are discussing that main important formula. So you need to remember that, Gogi, okay? Because they are very helping you in the exam, because in the exam you don't have time to see that which is allowed and which is not allowed reaction. So this formula will give you which is allowed condition and which is not allowed condition. So you need to remember this formula, okay? Write it here. It's very important for you, for the exam point of view. It's very important for CSIR, NET, SET, GATE, for all exams, because you need to know how which reaction is allowed in photochemical condition or thermal condition. So it's very important for you. Okay, thank you so much all of you for today's session. Thank you so much. Tomorrow we will take that different topic. Sir, can we say 4n plus 2 system allowed is heating and 4n system is allowed in H nu condition? No, Daneshwari, 4n means 4n means 4n and 4n is different. 4n plus 2 different. Naneshwari, for only Naneshwari or any other guys, okay? 4n system is different, sir. Why? 4n system, n is equal to 1, 2, 3, 4. 4 ones are 4. Means they are containing how much electrons? 4 pi electrons. If n I will take 2, so 4 2s are 8. It means if they are follow 4n rule, so they are following directly 4 table. 4 का टेबल फॉलो हो रहा है, लेकिन 4 का टेबल यहाँ पर फॉलो नहीं होगा. क्यों? क्योंकि यहाँ पर ऑड इलेक्ट्रॉन्स अलग होते हैं और इवन इलेक्ट्रॉन्स अलग होते हैं. यहाँ पे 4n और 4n वाला लगाएंगे नहीं. 4n और 4n वाला का लगाएंगे, यहाँ लगाएंगे. ठीक है, दैट्स इट. So you want to know that 4n electron is different and 4n pi electron is different. If you are taking 3, n is equal to 3, so if you 3 take 4 3 is 12. Here you see that that 12 pi electrons, 8 pi electrons and 4 pi electrons are only coming. After that there also you if you take n is equal to 4, you got 16 pi electrons, but they are all even. But here you got that 0 also, 2 also, 4 also, 6 also, but even number is different, and this formula is different. Don't correlate with him. Don't correlate with this. Okay, this is different and this is different, sir, because 4n plus 2 electron rule is different. Tomorrow I will tell you. This is different. This is only for odd electron upside, and this is only for even electrons. And even electrons, you know, got it, even electron pair. Even how many even numbers are there? Even numbers are 0, 2, 4, 6, 8. They are even numbers. They are not follow any rule between these two. Okay, and this rule is for odd electron, and odd electron rule is not followed by any rule. Okay, so odd electron pair rule is different and even electron rule pair is different. For we are seeing that H nu and photochemically allowed or not in this system is very different for you. Okay, but Daneshwari, but even electron there are also two ana, two electron pair also come there na, but in 4n system there is no 2. How you got 2? 2 is even or not? 2 is even. Okay, so in 4n system you got 2 pi electrons. How you take 2 pi electrons? What is the number of n? What is the number of n? How you take 2 electrons? 2, if you want to take 2 pi electrons, how you get from this 4n pi electron rule? because n value is very important. 1 2 3. If you put n value is 0, it's 4 pi, it's 0 pi electrons, and 0 pi electron is not containing any molecule. Okay, so you need to remember that 4n and 4n plus 2 electron is different. Okay, and this is different. Odd electron pair is different. Odd electron pair means odd number, bro. Odd number means which are odd numbers are there, sir? You know odd number. Odd numbers are 1 3 5. ये भी बताओ अब. is so basics. It's 8 7 9. ये कैसे है? 1 3 5 7 9 are odd, or even numbers are 0 2 4 6 8. They are even. They are not following any rule. Okay, they are different. Odd and even. You are very basic. Odd and even. Those who are not understand on odd and even, go to in 10th class and or 5th class. They are showing you even and odd number. Okay, this is very basic. So don't take personally. It's easy for you, and it's very easy. Don't merge the 4n and 4n plus 2 pi electron. It's very easy. Okay, and today's session, thank you so much, and thank you so much all of you. Okay, bye, have a good day. Naneshwari, now clear na? If you don't, if you have any query, you can ask me anytime. Okay. It's very easy.